I get infinity over negative infinity again.
Mm-hmm.
What do I do?
Love it.
Do it again.
2 over negative 2.
What's the answer?
Negative 1 third.
Now, if we write LH, will you still be okay, or do you have to write H for L'Hopital's?
Oh, you can write LH.
LH too.
I looked to his. I'm curious. Art, you or anybody in here? Am I get a solution manual? Did you feel free to look through it? Art, I don't know if you had a copy. If I have mine, I'll show it to you.
Okay.
He always writes the H. Puts an H over the thing. You know, just almost like to talk about that thing. I guess just that.
Okay.
All right, here's a tough one. That's a tough one. Just remember, how do you deal with fractions again? When you get a complex fraction, you multiply the reciprocal of the, because everyone, you all know ln of x is a 1 over x, and square root of x, what's the derivative of square root of x? You can remember that one, right? That's the one that comes up a lot. Oh, you're good. Did you just do it from memory? Josephine, very good. Oh, and first of all, let's just think about this. The square root of an infinitely large number. It's infinitely large. It's approaching infinity. Natural log. And when natural log is a very slow-moving graph, but it's also approaching what?
Infinity.
Infinity. Okay? So that's what we're trying to figure out. Is this, as this approaches infinity and this approaches infinity, is this overall expression approaching infinity, or is it maybe, you know, going towards some number, converted to a value? So, infinity over infinity, we got indeterminate form. I can put my true. Good. Now let's do the square root of x.
1 over 2 root x.
Zero root of x.
1 of x.
But now students get stuck. But you won't.
It's x over 2.
I want you to go ahead and reduce, you know, make that look better. That's crazy looking. We want to improve that. So how do you deal with this?
You multiply the.
So I'm not going to put this equal to the h symbol over it, because right now I'm not applying L'Hopital's rule again. I'm just going to simplify this thing. I'm just going to put an equal sign and say this is equal to whatever 2 square root of x, put it times, and put what?
X.
Now this could be the hardest thing, because we're going back in the day to algebra. How do you simplify x over
So
square root of
f
x?
is root x, root x.
That's a good way to look at it. And when you look at this, you want to break that down. Isn't x equal to a root x times a root x? Do y'all agree? So if you got to simplify this thing, isn't this just going to be this? Look. Square root x over 2.
Mm-hmm.
Is everyone okay with that? There's some ways to do this. That's x to a 1, that's x to a what? 1/2. But that's what's going on here. It's like one of these just what? Cancel it out. That's like a square root of x times. Everyone okay with that? You can look at it other ways. You can do a subtraction scale, like x to a first power minus x to a half power, right? Does everyone see that though? So Rod, that this over this is just the square root of x on the top. Yeah? So now this is going to be an interesting answer. Oh, and I now get to substitute this. Oh my goodness, this thing is heading towards infinity.
Mm-hmm.
You bet. Everyone, this function is heading towards infinity. The square root of an infinity large number over 2 is getting what?
Towards infinity.
Infinity large. Just think of the graph. Square root of x, just what? Taking off, right? What's this answer?
Infinity.
You might have solved this at the beginning. Do you have knowledge of these two functions? Square root of x versus natural log of x, which is this slowly, put, rising graph. So these values, as you approach infinity, tend to what? Get this large difference, and that's why it's going towards infinity. Does that make sense? Very good.
I don't get why you don't have to do it again, because if you plug infinity in, it's
It is
still
repeating.
infinity large.
If you do
I
it,
love it. I love it. She goes, why don't, we're not getting this. It may look like it. Look what you get. You get infinity over a 2.
So it's just infinity.
There you go. So we should talk about this. What if you get that? What does that mean mathematically?
infinity.
What if you got negative infinity over 2? What if you got, ready? Infinity over negative 2?
Same.
Negative infinity. Now I got a few others. It's going to happen in our next example. What if you got like 2 over infinity? I want you to think about it.
0.
2 over a million. 2 because these are limits. 2 over a trillion. 2 over quadrillion. What's it approaching?
0.
0. So when you see this, I want you to think that's roughly what? It's going to 0. The limit's going to be 0. Or what about this? Negative 2 over infinity.
0.
Or 2 over negative infinity. Again, I'm sorry, it's just going to be
0.
what? Because these are limits. We're saying if it's approaching that, if the top's like a 2, but the bottom's approaching infinity or an infinitely large number, you're like 2 over a million, 2 over a trillion, you're approaching 0. So do you see the differences in all those? That was good. So hey, Jess, on that note, look at my next problem. Don't take your time on this. It may look familiar, but it isn't. It's a little different. I want you to try that one. So again, Art, you might have a sense of this before you even start. That's good. That's good when you all have a numerical sense of what really is probably going to happen there. No? I like when you all have knowledge of these functions. And you're like, you putt-putt approach infinity. You know, in terms of height, this one grows more rapidly. So this is approaching infinity faster than this is. Do you follow me? You get a sense of what the answer would be. Alan, it's going infinity. That's going infinity. It'll be algebra. Well, Jess, go ahead.
If you did plug it in there, wouldn't you get the same answer? Because you would get, if you did the derivative again, you would get infinity.
Yeah, you're right. Sometimes that happens.
That's okay.
Yeah.
Okay.
The key is, though, you do want to stop right there.
Because I feel like I'm not gonna remember that.
Oh, I think you will know. No, you'll know. You're like, listen, I'll keep going when I see indeterminate form. But the minute I don't have any more, I'm substituting my answer in to get the value. Cool. Don't worry. I know what you're hitting at. I know you go, I don't know if I'm going to know when to stop. I got one coming up for you. You're going to like it before you leave.
This one.
All right, you ready?
Mhm.
Let's do Lopi with development of x.
1 over x.
Let's do that.
1 over 2 root x.
Oh, and I want you to multiply the reciprocal of the denominator so it looks better.
So it becomes 1 over root x.
Times 2 root x over 1.
2 over root x.
Sorry, 2 over root x. Sorry.
There we go. Now we're going to simplify this. That's a root x over an x. That means 2 stays in top, but the bottom now just becomes what? Jess, I'll be honest, that seems to be the hardest thing for students, to be able to write this neatly. And they get all confused. They're like, I don't know what to do now. We're just going to write it nice and clean. That's what that means. Now let's plug this in. We're going to know what's happening. Here we go. There's no L'Hopital anymore. Think about this value. What's the limit? 2 over 100, 2 over 1,000, 2 over a million, 2 over a trillion. What is that approaching? 0. That's the answer. You might have saw it at the beginning though. When you see the denominator function approaching infinity much faster than the what? The top, you might sense it, and that's a good thing. Can anybody know of a very fast growing function out there? Very fast. EDX. That was good. So watch this. What's your hunch on this problem? It's very similar to this. What's your hunch? And then we'll do Lopi's. Then we'll do L'Hopital's. That's a very rapidly, right one? It's exponential growth, right?
Mhm.
And I'm just going to do like something, you know, x squared or prep. Who's approaching infinity faster?
Exponentially.
So what do you think is going to happen? It's going to be
0.
very similar to this. What do you think will happen?
0.
0? And if you flip it over, guess what it'll do? It'll go to infinity. That's when you have really good sense of this stuff. But everyone, you want to have fun and do L'Hopital's rule? But everyone, we're all saying this. We're like, we'll do L'Hopital's rule, but we get this. That's moving much quickly towards infinity than this guy, right? Just let you go, how do I know that? Everyone, just let, am I gonna calculate handy? What's 10 squared?
100.
100, right? Okay, what's e to the 10th?
Huge number.
What's e to the 10th?
22,000.
22,000. So at x equal to 10, this guy's way ahead of you, follow me? So like you're getting much bigger quickly, right? Or quicker than the other one. And so you're like, yep, this thing's approaching
Is
zero.
e the
Does
fastest
that make
function?
sense?
So when there's
And if
the
you flip
difference,
this-
when there's the difference in,
Yep. And the denominator has the faster one, right?
so when there's like a big difference, then that means that the.
That's
answer is
right.
0.
That's right. That's what we gotta look at. That's why, and you, the way you're looking at Sandberg, that's what L'Hopital was looking at. He's like, wait a minute, we don't know the answers because something might approach it quicker than the other. So I want us, hey, can we do the math? We're all saying we should get 0 here, right? Let's see. I can do L'Hopital rule. Let's start x squared.
2x.
What's your EDX?
It is our x.
Now look at this, Jess, because this is what Jess was talking about. Jess, I can go again. Because infinity of infinity. What's your 2x? So I get to h, there's my h, I get 2. What's your VDX? Now, everyone, I have no more indeterminate form, it's now time to what? Substitute infinity. So what's 2 over an infinitely large number?
0.
Anyone on that note, I love to do this. Flip it upside down.
Is e the fastest function? No.
Great question. You ever seen this guy? I bet you say yes.
Oh, yeah.
Who knows factorial? Is there something out there that can beat factorial? What was e to the 10th? I forgot. Alright, what's 10 factorial? Do you know where the button is? Go to math, PRB. Someone's gonna tell me it's huge. It's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1.
3.6288 e to the 6.
And what does that mean? Scientific notation, it's huge.
Oh,
Right? This is my favorite. What calculator you got?
Casio. It's regular.
Does that do, does your Casio do 70 factorial? Or is it too big?
Let me see.
Sometimes when the factorial is just too big. Calculator. It's too big? Thanks. He's saying the TI-84 can't even do 70 factorial. Now if you're like, I've never seen a factorial before. If anybody in here, I want to tell you what a factorial is. 5 factorial looks like an exclamation point. It's 5 times 4 times 3 times 2 times 1, which is like 120. What's 4 factorial? 4 times 3 times 2 times 1, which is just what? 24? Okay, but this explodes very rapidly. You saw what happens at 10 factorial. That thing was gigantic. He says a calculator won't even do 70 factorial, it's too what? It's too big. So, alright, I'm gonna write a limit on the I don't put this on the test, but I wanna see if you can get this. Art, do you know this answer? I got EDX up there, that's a fast growing but I've got this guy in the bottom.
Oh, then that should be 0.
Yeah. If anybody's curious. Don't worry, I don't think you'll see that factorial symbol anywhere in this section. You'll start seeing it in Calc 2. Might as well give you a head start on it, right? Get used to it, right? And then you go, this is my favorite. You go, well, is there anything that can beat factorial? And you go, yep. How about that guy?
Huh.
This is fun. You go, yeah. All right, if you beat that, anybody can beat that guy? How about x to the x? And at 2, it's 2 to the 2. At 3, it's 3 to the 3, right? What's going on at 10? 10 to the 10th power. What's going on at 100? 100, so that thing's even
What
blowing
about-
that thing out of water.
What about x to the x factorial?
Oh my gosh, see? This is not even me and him. We can go on and on and on. Keep getting something that's just approaching infinity more. Or you're like, how about this? The x to the what? You know? Well, like, alright, that's enough. That's enough, right? It's fun though. It's fun. Alright, Owen, try this guy. Now, if you already know the answer, I'm very proud of you. Seriously, it means you have good number sense. You try that? If you're like, oh, I know what this is.
Yeah.
That's pretty darn good. I mean, you know what it is, and you're that confident in your math skill, please feel free to put that answer down, but it's coming out of this section. So it's like, let's practice Slippy Towels rule, but I'm serious, on a test. Sarah, if you put the answer down and I didn't see any work, I'm okay. Right? It shows you have really good number sense, you understand limits. This guy's blowing this thing out of the water as you approach what? Infinity. Well, first of all, I can apply L'Hopital's rule, so I'm going to show how it works. Let's do a V to 2x. Is that right?
No, 2e to the very
No.
least.
Alright, chain rule. You know it. It just comes up so often. Let's do a V to 2x. Either 2x times up.
2e to the 2x.
What's your x cubed? Just 3x squared, right? Jess, I get infinity over infinity again. So now let's do that.
4,
E to the 2x.
6,
Oh, goodness gracious. I get what?
8.
Infinity over infinity again? It's almost like Jess, I keep going until I get a constant somewhere, huh?
So there's not an X on it.
I like that. Yeah, you're right. That's a good eye. Because every time there's an x, you're plugging this in, you're getting an infinity on one of the parts. What's that derivative? 8. But when I've seen people on tests do this. No, I mean, they did all this great work, I'm telling you. And I'm like, gosh, that just did nothing for them. You might have saw it at the beginning. What's the answer?
Infinity.
Yes, I love that. Because now you plug infinity, you're like an infinitely large number over 6 is positive infinity. Right? What's some other tricks you can do? Especially in a multiple choice exam for a final. What's some other tricks? You know what you can do? I'm just going to see what e to the 2 times 100 is over 100 cubed. And just see if the number is like humongous or something. That means it's heading toward infinity, Caleb.
Is our whole final like multiple choice?
Nah, that wouldn't be nice. You may hate this stuff. So I like to do both. Do like some free response questions where you get